What you just saw is the result of what we are building today, a rather speedy Ender 5 Pro. Right now though, it's bare bones and stripped down from my last attempt. We're going to take this and make it faster than ever, so let me give you the rundown. Due to popular request, I'll be running the Mercury 1.1 conversion, but to take it one step further, I'll be running all-wheel drive as well. That means more motors, more torque, and ultimately, more speed. I asked BigTreeTech for some help and they sent over a care package with the additional motors and more. The LDO 2504 Speedy Power motors have quickly grown on me and you may have been able to spot them putting in the work in my previous builds. To power them, I'll be running a BigTreeTech Kraken, the most insane mainboard I have ever tested. Look how it dwarfs a standard Ender 3 sized board. With up to 60 volt support for the motors and 8 amps of driving current, I could run something much stronger than NEMA 17s. With more ports than I need times 2, this board is perhaps the only overkill part of this build. I love it. For extrusion, I'll be running the Orbiter V2 and a Trianglelab STD6, which is also the most high performance combo I've ever used, and for cooling, BigTreeTech sent over their turbo CPAP kit, which will actually be necessary for the speeds I plan on reaching. FunSource sent over an X-beam which will knock the moving mass down, Marble 3D provided some carbon fiber PETG for the printed parts, and yeah, I think that's the plan. Let's get started with the motion system. And just like that, they're all done and ready to be used. It's such a little thing, but I absolutely love how these guys look. They just make it look a little bit more refined. Some of the designs here I'm finding while installing the parts are actually amazing. Speaking of amazing, this video is sponsored by PCBWay. They are your one-stop shop for CNC machining, laser cutting, 3D printing, and PCB fabrication services. They are also currently hosting their 7th project design contest with thousands of dollars of prizes to be won. If you want to have a go, entries will be open until the 19th of January next year. And as always, there will be a link to PCBWay in the video description. This little printed helper tool that helps get the shims and bearings in place is actually incredible. I have fumbled around for ages in previous projects without these, so it's really cool seeing them implemented here. These are the parts for the x-axis, but we also have this. This box was sent in from Funzor, and it's honestly so light, I'm a bit worried it might just fly away, but we should be alright. Let's get it installed. Wow, it genuinely weighs like next to nothing. That's really cool. And the scale says 80 grams. That's nothing. Even though this extrusion isn't as long, it's still over 50% heavier. Quite a difference. There's an odd number of holes, so I'm going to position the rail more to the left side since I'm assuming that's where it's going to be homing. This is going to look so cool once it's installed. I have been looking forward to this part for ages. That's looking so cool now. A hands-on project like this has also given me a much better understanding of how things work, which is really cool and probably the best takeaway from this entire project. First step is actually reversing what we did and flipping the bearings to go down here and this idler to go up here. Alright, that's both sides bearing stacks and the pulleys done. Now we can move on. This is going to explain why we need so many shims and bearings. It's certainly a cool looking assembly. I was having some issues installing the pulleys onto the version that I've got, so I talked to the author of the mod and he's provided me with a newer version, which is stronger, supports double shear if you have longer motors, and should fix the issue I was having with the wrong sized pulleys. So before I was actually having clearance issues with these pulleys. They weren't able to rotate freely, they were too close to this part here, but now everything is looking all good. I think this is a really cool design as the bolts act as internal strength and also we can attach the motors to the top. It's pretty cool. As mentioned earlier, my linear rails are a bit too long, which is causing some issues here. I can just design a custom tensioning thing so that it can compensate for the extra length. And by using some M5, what are these called again? The M5 nuts that go in the channel, we can install this. They bolt down nice and strong, no worries there. It's rather amusing actually, I've never really used bearings in any of my projects and now I've used more in this one than ever before. Okay, so I'm just going to play a bunch of footage on the screen real quick for some context. So I was trying to add double shear, I have these decouplers, I've tried adding, it just would have been a bit too jank if I tried to make it work with all the stuff I've got. So I think the only option is just next time I'm going to get longer shafted motors, maybe the Kraken motors, since they will work with the double shear integrated in here. It'll just make things simpler. Unfortunately, we won't be adding double shear this time. There's nothing I can do about that, unfortunately. And the thing is, this looks so cool as well, aside from the poor print quality on this part, but that's my fault. That is looking so cool so far. Alright, so here's the hot end extruder assembly that I'll be running. It's comprised of a Trianglelab STD6 and a Orbiter V2. The problem is, the hot end is extra long, and I need to get everything to work well together, so I think I'm going to have to design my own toolhead for this. It's nothing fancy, just something basic, but let's unbox the turbo CPAP system because I have been dying to open that. both boxes are unlabeled, so this one's heavier, so let's open the heavier one. Sweet. I'm guessing the other one is just accessories. And then this must be the driver. Sweet. Feels like I'm in the garage, not the studio now. And that's the whole system sorted out. I don't know if these are some kind of Vargel connectors, but they're really fun to play around with. They've got a nice little click when you close them. I mean, honestly, with all these pre-tinned and crimped connectors and everything that works together so well, BigTreeTech's done an awesome job here. Thank you again for sending me this. So yeah, that's our cooling and extrusion setup. Now I just have to design a tool head that can take advantage of all of it. Okay, so I've made a little mistake with the dimensions. I made a spot for the end stop here, but it's way too thin, and you may also notice that it's the only thing holding this part together. So look at this wobble. That's really bad. I downloaded some different end stop mounts that we can use, so I'm gonna print this again, but make it much stronger. This is as packed as the studio's ever been. We got the Ender 3 running, we're working on the Ender 5. In the back, we've got the new Frozen machine. The broken 3D printer is fully broken. We've even got a brand new Ender 3 down there for a January video. Stay tuned for that. Things are ramping up. It's very exciting. All right, that's V2 done. Not too bad and a lot stronger than before. And if we want to have some fun and compare the strength between the two, well, this one's like that, and this one I have to actually, well, I can't bend it. The side profiles also show how crazy of a difference this is, and that no matter how much time you spend on V1, there will always be issues. Well, except for my designs, there'll be issues in every version, but we don't talk about that. And now that's the heatset inserts sorted on both sides, and I've got some expansion ports here in case we want to add something like cable management or such. Best part is, this part is super simple to install. We just put it on like that, and it's all ready. The toolhead will mount to the front, the CPAP stuff will mount to the back, and there's some screws to bolt it to the linear block. Luckily, I've been collecting different sizes of bolts and now have the exact perfect ones I need. So far, this is one of the strongest and most rigid designs I've done for a tool head. I mean, I've only designed like 2 or 3, but yeah, the more practice, the better. Alright, super excited about this part, installing the tool head. Over time, I definitely want to get better at designing things and making them so that they're easier to assemble and that sort of thing. Better printing orientation, better assembly. That's as tight as I can get that. All right, I removed the extruder, and if I remove the fan here, easy access. Now, the problem is, of course, for a hot end this long, there's going to be a little bit of wobble. Well, I think that's as good as I can do it for plastic. I know I could get this whole thing done out of metal, have a laser cut top plate, back plate, and front plate, but I just want to test this. It will work, and we'll see how fast we can go. Okay, and now we reassemble. That's our tool head looking good. I've only been chipping away at this day by day, and this is like the biggest leap in progress. So I'm really happy to see this. So it's getting a bit late, and we've made good progress for today. Getting a bit dark outside now. Weather's good, so we'll continue on tomorrow. Oh, this is awesome. So there's a little issue where if I move the carriage, the CPAP tube is going to drag along, so we need some way to bring it up like this and also hold the cables, which is where that part comes in. This could be better, but should work. Actually, I could probably improve that with a few spacers. Alright, the spacers worked out, so now I think it's good enough. Also, you may have noticed that I'm actually losing a lot of Y travel with the way things are set up here. I've designed version 2, which removes these spacers here and moves the whole CPAP system a little bit more forward, giving us a little bit more Y travel. Also, I don't know if we're at the 10-minute mark or the 20-minute mark in the video, but please let me know your thoughts on longer videos. Less highly edited ones, because yeah, it's what you guys want. I also thought ahead and actually bought some cable sleeve wrap wire stuff. Alright, I might need to double check, but essentially I think that's the final belt path there, having it go all around. Yeah, that's pretty cool actually. I've duct taped the assembly for now, it's holding together, but essentially all the belt paths are now done. It took a little while since I was a bit confused, but I've got a better understanding of it now, and it's looking almost operational really. One of the heatset inserts wasn't very good, and when I tried to fix it, I ended up pulling it out. So I'm gonna reprint that thing, make a few changes and make it better. And then we can get the belts fully installed. It's gonna be awesome. Quick disclaimer, I did make a little mistake and I fixed it now. This belt was round the wrong way. It got a bit caught up in this motor mount here, but we're all good now. This is an exciting update. We've got all the belts properly installed now. It's looking really cool. I have noticed a little issue though with these tensioners. They are starting to pull out the insert, the heatset insert. I'm gonna have to figure something out with that. I've reprinted the Toolhead part with version 2, which is a little bit shorter at the back. So the whole CPAP system isn't as long as it was before. It's a lot more rigid. It sits a lot better. Now we can move on to finishing up the CPAP system. Alright, so we need to put the main board in here, but we also have to deal with all this power supply stuff. Well, this is going to be a mess either way. This is the layout I've come up with. It is the 2 power supplies, 48 volt in the back because it's a much larger unit, 24 volt up front. You can see how much slimmer it is. The main board in the back, since most of the cables are going to be back here, and then the Raspberry Pi up front. I'm not going to be able to make a case for it all just yet, but as long as we can get everything working, that's good enough for me. That's our main power cables done. So the first little problem that you can see is that the large motor connectors are larger than the smaller ones. BigTreeTech does provide new connectors that can be used. I just have to crimp them myself, which I've never done before, but should be alright. So it's actually a lot easier than I expected, so I'll walk you guys through it. So we've done the black wire first, now we're going to do the green one. Now we push down on this little tab here for the green wire, and then we can pull the green wire out. And we take our connector tab thingies. To remove these pieces, you can cut them, or you can just bend them back until they snap off. Now we take our new connector, we take our old connector, and I'm going to do this. Now we install it into the tool. We now press down on the tool, and now we have a super strong solid connection which we can install into the connector. There we go, that's 1 done. That's 2 done so far, and that's all 4 done. And now we test the power. Okay, stuff's turning on. The Kraken has turned on, but the fan for the 24 volt power supply has not. The Raspberry Pi LED has turned on too. Actually, it looks like the 24 volt power supply does have power since the little green LED is on. It's just the fan's not spinning. I'm sure it will turn on once there's a load. Sweet, we've got the clipper interface online. It's obviously not connected since we haven't hooked it up properly digitally. But I will do that now. If we do this, the heated bed and the extruder should both work. They both work, but the hot end needs a PID tune. This is why PID tuning is important. Do you see that? Is that steam? Smoke? Steam. Must be pretty hot now. Actually, never mind. I think that's because this is the first time heating up the hot end. I also set it up so that the hot end fan only turns on when the hot end is actually heating up, and it will turn off when it gets below 40 degrees. Okay, this is cool. Now I can control the auxiliary and the CPAP fan from Clipper. And they got the correct names too. Check this out. It's loud. And the same goes for the auxiliary. Awesome, so much airflow. This is with both of them running. I'm sure it's pretty loud. Since I'm most confident about the Z-axis, let's try homing it. Wrong way, buddy. All right, I'm now gonna carefully home the X-axis, and I'll be ready to stop the machine at any moment. Okay, that's great, it's moving. Wrong direction, I can fix that. Take 2, the Z goes down, and now it's going in the Y direction. All right, take 3. Yeah, awesome. Okay, and it should stop moving when it gets to there. Awesome. Now for the Y-axis. Yes! Oh, that's amazing. And finally, Z-axis. What is it doing? Oh, never mind, here it comes. I think that's because of the safe Z home command. I just need to move this guy back a little bit. Sweet. All right, so here's my little plan. I'm not gonna be able to fix the wiring in time because it's already late November, but you see all these red parts. Not only are the heatsink inserts coming off, that is far too long, it's not good. Those are red, so I think we should stealth black this machine. Remember, this isn't supposed to be an indicator of quality. This is about sheer, stupid speed. And I'm all for it. I have to hold on to the machine and my laptop so that they don't fly away. Alright, that's 1 minute in. We're looking really good so far. This filament cools really well. Alright, now I'm going to bump the acceleration up to 110. So that's 800 millimeters velocity at 110 millimeters per second squared acceleration. The filament holder in the back keeps rattling around. I taped a drill to the table to keep it in place. The funny thing is, mainsail can't even keep up. I have to reload the page sometimes just because it doesn't update. I think the Raspberry Pi 02W just can't keep up. 2 minutes in, by the way. I don't think we'll run out of filament, but we're pretty close to. Okay, it's about to get insane in a second here. Should be right about now. Everything on the table is shaking. 334! Where's the scraper? Obviously not good. Obviously not bad. For the speed. That's funny. That looks better than my 8-minute ones and then my 5-minute ones on the other machines. Oh yeah, I need to do a little... There we go. Now we can easily tell. Wait for it. Now. And then CPAP, 100% once the first layer is done. Okay, I'm going to enable it now. It should turn on right. Perfect timing. The goal is to get something that's at least 80% quality in under 10 minutes, because that's more than enough for everyday printing. And I'll link the full video in the description. This isn't even the filament that I love to use for high-speed printing. I've only got enough for one Benchy left, so I'm just using this eSun stuff that I had on hand. It came with another printer I bought. Alright, I've got to get ready to stop now. Looks like we'll be getting sub 9, which is always good. 854. The CPAP system is so loud. There we go. Definitely not perfect. I'm not sure if that's the Z-axis holding us back or belt tension. These belts are not as tensioned as I would like them to be. But honestly, for sub 9, that's pretty good. Not perfect, but pretty good. Awesome. So, what to talk about now? Well, I would first like to say a huge thank you to PCBWay, BigTreeTech, Funsort, Trianglelab, and Marvel 3D for providing parts and support for this build. It made a huge difference and I'm honoured to work with you. A special thank you to Mitsubishi Makes and his tuning videos and support, and a huge thank you to Andrei Stanciu. Andrei is the creator of the all-wheel drive mod for the Mercury 1.1, and he has been answering all of my many questions, helping me troubleshoot the build and even design new parts for me, like these tensioners and these new blocks for the different pulleys I had. I also ran into an issue where I couldn't find the ID for the Kraken mainboard, and we spent a good couple of hours together getting that sorted. Without him, I would be even more overdue for this project, if not completely lost. I've linked his GitHub page in the description if you want to have a look at the various all-wheel drive mods he offers for the Mercury 1.1. Once again, thank you, Andrei. As for the price of this whole build, assuming I paid for everything, excluding time, it's roughly 1100 New Zealand dollars, or about 650 USD. Which, when factoring the printer's cost itself, is almost the same as a Bambu Lab P1S. So that's something to consider if you're looking at a printer for printing rather than tinkering. Since a lot of the parts were provided, I didn't spend nearly that much, but if you're looking into a fun but somewhat challenging project, it's still a good option, and I think good practice for the next stage, which I think would be building a Voron or rat rig or such. Which hopefully I'll be doing sometime around February next year. We will see. If you have any questions or feedback, please let me know. And as for now, this project is done, but maybe I can finish it off next year with a few more improvements. That is all from me though, so thank you so much for watching. And actually, I have been working on this video for so long. I started it in like winter. I think I shouted out this video in like my March video of the Ender 3. It's now summer. It's like really hot in the studio. I'm glad to get it done, but yeah. Well, we will see. See you guys next time.